Hey everyone, and welcome back to Animal Notebook. So today we're taking a look at one of the most absolutely vital yet kind of misunderstood creatures on the entire planet. We spend so much of our time building these incredibly complicated machines and massive global supply chains. But right under our noses, nature is quietly pulling off planetary-scale logistics using nothing but flower dust and, well, collective obsession. Today's explainer is all about the awe-inspiring world of bees. Okay, let's dive right into this. When you picture a bee, you probably picture a very specific, fuzzy yellow and black insect buzzing around a hive. But the crazy truth is, there are over 20,000 known species of bees out there, spanning 6 different continents. They literally exist in every single habitat that has insect-pollinated flowering plants, from deep, humid tropical rainforests all the way up to high-altitude mountain meadows. To truly understand these fascinating creatures, here's our roadmap for today's explainer. First, we'll meet the bee. Then, we'll go inside the hive, explore the global web, look at saving the swarm, and finally, wrap up with some frequently asked questions.
All right, Section 1. Meet the bee, taxonomy and anatomy.
So, taxonomically speaking, bees belong to this superfamily called Apoida. They're flying insects that are incredibly closely related to wasps and ants. Actually, their evolutionary history tells this really fascinating story. Bees essentially evolved from predatory wasp ancestors, but instead of hunting other insects, they made this massive dietary pivot. They completely switched to gathering pollen and nectar, effectively becoming, well, vegetarian wasps? They're just perfectly equipped for a life among the flowers.
Now, what's really interesting is the sheer amount of specialized biological tech packed into that tiny little frame. For starters, they actually possess 5 eyes. Yeah, 5. They've got 2 large compound eyes that are incredible at detecting motion, and then 3 smaller simple eyes called ocelli, right on top of their head to measure light intensity for navigation. Plus, they can literally see ultraviolet light, which helps them spot these hidden, almost runway-like nectar guides on flowers. And if you look closely at their hind legs, you'll see many female bees have these smooth concave zones fringed with stiff hairs. Those are called corbiculae, or pollen baskets. They use them to pack and carry these little compressed pollen pellets right back to their nests.
Moving on to Section 2. Inside the hive, social structures. Okay, so when we say the word bee, we almost always picture this massive, highly cooperative colony, right? Well, get ready to bust a huge myth. Shockingly, 85% of bee species are actually completely solitary. That means for the vast majority of bees out there, like your mason or leafcutter bees, every individual female is fertile. She works entirely alone to build her own nest, lay her eggs, provision them with food, and then she actually dies before they even mature. Only about 10% are what biologists call highly eusocial, which includes your famous honeybees. But for that highly organized 10%, their social structure is an absolute marvel of biological engineering. A typical honeybee hive is strictly divided into 3 distinct castes. First up is the queen. She's the single fertile female who maintains her authority using chemical pheromones, and she can lay an astonishing 1,500 to 2,000 eggs every single day. Just incredible. Second, we have the workers. These are sterile females that execute literally all the manual labor in a process called polyatheism. Their jobs actually shift chronologically as they age, so they start out as nurse bees, transition to comb builders, then guard bees, and finally they become foragers. And third are the drones. These are stingerless males whose exclusive biological role is to mate with queens from other colonies.
And this brilliantly illustrates how they make this incredibly complex society work. They've developed one of the most advanced communication systems in all of nature, the waggle dance. Discovered by ethologist Carl von Frisch, it works like this. A foraging bee will return to the vertical honeycomb and literally perform a stylized rhythmic run. The angle of her dance relative to straight up on the comb tells the other bees the exact flight angle relative to the sun, and the duration of the waggle, that tells them the distance. Roughly 1 second of continuous buzzing equals about 1 kilometer of travel. It is totally wild to think that humans spend our time inventing things like, noisy leaf blowers, while these tiny creatures are translating complex spatial metrics into symbolic, geometric dance routines.
Let's move to Section 3 and see how this builds into something even bigger, the global web, ecological impact.
So bees are what biologists call a keystone species. That basically means their entire environment relies heavily on them just to survive. Check out this staggering reality. Out of the top 100 crop species that provide 90% of the world's global food supply, bees pollinate roughly 70 of them. By just going about their day, Moving pollen from the male anthers to the female stigmas of flowers while they forage, they enable the fertilization that actually grows our food.
Just to make this incredibly personal for all of you watching Animal Notebook right now, approximately 1 out of every 3 bites of food you consume relies directly on these animal pollinators. It's not just some nice ecological bonus. It is literally the foundation of global agriculture. To put that into perspective, the entire almond farming industry is 100% dependent on honeybee pollination. Without migratory beekeepers bringing in massive truckloads of hives, global almond production would just instantly collapse. 0 almonds.
Which brings us to Section 4, Saving the Swarm, Threats and Pressures.
Objectively speaking, global bee populations are currently facing a really intense gauntlet of synergistic stressors. First, there's colony collapse disorder, or CCD. This is a phenomenon where worker bees just abruptly desert a seemingly healthy hive. It's often triggered by a combination of factors, including systemic neurotoxic insecticides like neonicotinoids. And the scary thing is, even at sublethal doses, these chemicals impair a bee's spatial memory and navigation. That effectively breaks that incredible waggle dance system we just learned about. Then, you add in massive habitat loss from monoculture farming, plus devastating parasites like the Varroa destructor mite, which feeds directly on adult bees and vectors lethal pathogens like the deformed wing virus. All of this combined pressure is severely endangering both global biodiversity and, quite directly, our own food security.
All right, Section 5, Frequently Asked Questions. Let's jump right into our rapid-fire round and test some of that new knowledge. Question number 1, and this is probably the single most common question out there about bee defenses. Can all bees sting?
The answer is an absolute no. Only female bees actually have the ability to sting. And the reason for this is that the stinger is really just a modified ovipositor, which is an egg-laying organ. Males simply don't have them. Furthermore, it's really only worker honeybees that die after stinging mammals. That's because their stingers are barbed, so they get caught in our elastic skin. Most other species, like your bumblebees or solitary bees, they have smooth stingers, meaning they can strike repeatedly if they feel threatened.
Let's move to question 2. Do all bees live in massive colonies?
Not at all. Remember that crazy statistic from earlier? A massive 85% of bee species are completely solitary. So species like mason bees and leafcutter bees, they work entirely alone. They build their little nests in hollow reeds or tunnels, totally doing their own thing without a queen or a massive colony backing them up.
Question 3. Does pure honey ever go bad? I mean, you probably have some sitting in your pantry right now, but what is the actual expiration date on this culinary miracle?
The answer is literally never, because worker bees fan the nectar with their wings to remove the moisture, and combined with honey's naturally high acidity, it is essentially eternally preserved. Get this, archaeologists have actually excavated ancient Egyptian tombs and found pots of honey inside that are thousands years old, and yes, they were still perfectly safe and edible. No way, right? But it's absolutely true.
And our 4th and final question, how fast can a bee actually fly? We see them constantly looking so busy and frantic, but what is the top speed of that tiny, fuzzy little body? They can hit roughly 15 miles per hour. So the crucial point here is this. Not only is this tiny insect hitting 15 miles per hour, but a single worker bee might visit literally thousands of individual flowers in just one day, all while carrying compressed pollen on her legs and navigating via the sun's angle and ultraviolet light. It's just a stunning, absolutely gorgeous display of biological efficiency. Which really brings us to our final thought. The food on our plates, the health of our wild spaces, and the delicate balance of our entire ecosystem, it all rests on the wings of these diverse, endlessly fascinating creatures. So here's a question for you. If our entire modern civilization relies on the silent daily labor of these tiny, buzzing insects, what are you going to do to ensure they keep flying? You can start small. Plant some native flowers, reduce your pesticide use, maybe support your local beekeepers. Thank you so much for joining me on Animal Notebook today to explore the amazing world of bees. Keep learning, keep asking questions, and I'll see you in the next explainer.